Well, hello everybody. Here's what you missed the other day. Overall, it was a review day. What I did is I took the factoring, the completing the square, and the quadratic formula, and we mixed it all together. The reason I did that is each of them are ways to find the correct answer, but some of them are faster than the other. So what I'm going to work on today with you is what's the best method to use to find the solution. So there are the answers to the worksheet that I collected last time. You can check those, make sure you get those correct before I collect them. You can always pause the video, finish looking at them. But those are what your answers should have looked like. We will have a quiz coming up on those, so make sure that you understand the material. Now, I've got a couple of slides here that if you're here, I'd answer questions for you. But hopefully you got your note sheet right in front of you. Here's what I need to do today. There's three different ways that we're going to look at to solve an equation. If you have that factoring sheet that we came up with, I called it the factoring flow chart. We're going to use that a little bit today. Because if you could use that flow chart on the first four methods, which I'm going to review with you real fast, that's the way you want to factor. Our next option is going to be completing the square, and then the last but not least will be the quadratic formula. So let me just review the factoring types with you super fast. ax squared plus bx, that means there's something in common. An example of that would be 5x squared plus 15x. That's where we pulled out whatever they had in common, a 5x, which left an x plus 3. If you look at your flow chart, another type that was on there is what we called a difference of squares. Something like 25x squared minus 16. If we saw that, that's where we factored it into 5x minus 4 and 5x plus 4. And then we're still going to set these things equal to 0. So 4/5 and negative 4/5. The third kind of factoring on your review sheet would be something of the sort, let me come down here, would be something of the sort x squared minus x minus 6 equals 0. That's where you had to go find me two numbers that multiplied to be 6 that you can make add up to be negative 1. So in this case, negative 3 and positive 2. And then the last kind that we're going to concentrate on your flowchart there is the perfect trinomial. Remember, that's if the square root of the first number times the square root of the last number doubled equals the middle number. Kind of what we just did with completing the square. Now notice I'm going to leave off that hard kind of factoring that's on our flow chart, because if it's a hard kind of factoring, we're going to come straight to the quadratic formula. Now sometimes we're going to use completing the square. Completing the square is a very, very good method to use, but it's best to use it when the value of a is 1, so there's a 1 in front of the x squared, and the b value is even. And I'll review one of those with you here in a second. But otherwise, boom, we're going to go with the quadratic formula. The quadratic formula will solve every problem, but it's a slow way sometimes. So follow along with me on your sheet here. Look at 36x squared equals 0. When we look at these, we're going to try to decide, is it one of those kinds on my factor sheet, that factor flow chart? And number one is, it's a difference of squares. So I'm going to factor this into 6x minus 7 and 6x plus 7 equals 0. Then I'm going to go get my two answers. Add 7, divide by 6, subtract 7, divide by 6. And then we got it. I could use the quadratic formula on this, but man, guys, A would be 36, B would be 0, C would be negative 49. That's some big numbers. Here's my number 2. X squared minus 7x equal 18. I'm still going to look to see if it's one of those on the flow chart. So here's what I need to look for. Can you quickly, and keyword quickly, can you quickly go find me two numbers that multiply to be 18 negative, but add up to be 7? If you can, then it's easy to factor this. If you can't, then we're going to go to the quadratic formula. Well, in this case, 2 and 9. So I'm going to think of this as x minus 9 and x plus 2 equals 0. So my two answers, 9 and negative 2. So that's what we want to look for first. Here's number 3. I'm still going to look to see if it fits on my flow chart. There's some numbers in front of there, but peek at this. Do you know the square root of 4 and the square root of 25? Well, the square root of 4 is 2. The square root of 25 is 5. 2 times 5 doubled is 20. So I know this is a perfect trinomial. So this will factor into 2x minus 5 quantity squared equals 0. My sole answer, 5 over 2. Hey, so on 1, 2, and 3, I just reviewed factoring with you. On number 4, when I look at it, as soon as I see a number right there that I don't know the square root of, I'm going to go straight to the quadratic formula. The quadratic formula is the best in this case. So to review the quadratic formula with you, remember if you don't see it on your sheet there, which I have on your sheet, but it's the opposite of b plus or minus b squared minus 4ac all over 2a. Just like we did last time. So here goes. I'm going to have negative 14 plus or minus the square root of 14 squared minus 4 times 3 times negative 5 all over 2 times 3 is 6. And then remember, grab your calculator and go find the value of the discriminant, the b squared minus 4ac part. I did that for us already since this is a video. This comes out to be 256 all over 6. Your next step, break down 256. In this case, it's a nice square root, 16. All over 6. Now let's go start working on our answers. I got negative 14 plus 16, which is 2 over 6. A better name for that is 1/3. Negative 14 minus 16 is negative 30 over 6. A better name for that, negative 5. So I reviewed kind of the factoring so far and the quadratic formula. Let's take a peek at your number 5. First, I want to see if I can factor this, because if you can, that's the fastest. In this case, though, number 5, if you try to find two numbers that multiply to be 7, but add up to be negative 6, you can't do it. You could say, yeah, we could, Mr. Harris, negative 7 and positive 1. But if you multiplied those, you would get negative 7. So those don't work. So what I'm going to do on this one, since A is 1 and B is even, we're going to do the method called completing the square. After you see it, it's going to sound familiar. So I'm going to rewrite this like this. X squared minus 6x plus blank equal negative 7 plus blank. Remember, this 7 goes to the other side and the sign changes. Hey, now, to get this number that goes in the blank, half of your b term squared. So half of negative 6 is negative 3. Negative 3 squared is 9. Now remember, guys, the reason we completed the square is so that I could write this as a perfect trinomial. So this becomes x minus 3 squared. And on the right-hand side, it becomes 2. To bring it home now, I'm going to square root both sides. So on the right-hand side, I have positive, negative, square root of 2. To solve it for x is going to be positive or negative square root of 2 plus 3. Or you could write it as 3 plus or minus the square root of 2. So that's the method called completing the square. You could do that problem via the quadratic formula, but believe it or not, it's a little bit slower because you have to reduce and then take out a number. Number 6 is another one just like it. I cannot find two numbers that multiply to be 4 that I can make add up to be 8. But in this case, A is 1 and B is even. So I'm going to attack it by completing the square. X squared plus 8x plus blank equal negative 4 plus blank. And then think for a second what this number will be. And hopefully you saw 16. Half of 8 is 4. 4 squared is 16. So I'm adding 16 to both sides. On the left-hand side here, this becomes x plus 4 quantity squared. Quick trip down memory lane. I got this x because of the square root of x. I got this 4 because it's the square root of 16. It's also half of 8. And on the right-hand side, I have 12. Let me square root both sides. So I got x plus 4 equal positive or negative square root of 12. But when we can reduce a radical, we got to reduce that. So I'm going to think of this as the square root of 4 times the square root of 3. So I now have x plus 4 equal positive or negative 2 radical 3. Square root of 4 was 2. Solve this thing for x, so x is going to be negative 4 plus or minus 2 radical 3. Hey, notice that the 4 was positive here, so it's negative over here. So there's my answer. Like I said earlier, if you would write that as positive or negative 2 radical 3 minus 4, I'm going to be okay with that. Flip over to your number 7 if you would. Try to decide what method it is, but here's what we're going to do. As soon as you see a number right there that's not a number that you know the square root of, we're going to go straight to the quadratic formula. So I've got the opposite of b, so I got 3 plus or minus b squared. Since that's a negative number, guys, remember to put that in parentheses. So negative 3 squared minus 4 times a times c all over 2 times a, which is 4. I'm going to go 3 plus or minus the square root of something over 4. And then you'll grab your calculator and make sure this negative 3 is in parentheses. So negative 3 squared minus 4 times 2 times 11. And when I did that, I got negative 79. So something I know, there's an I in this answer. So my answer, 3 plus or minus I square root of 79 all over 4. I'm done because the square root of 79 does not reduce. So we're done. So now when I look at your number 8, when you look at it, we could use the quadratic formula. That's the slowest. I could use completing the square. That's the next slowest in this problem because this one factors. Can you find me two numbers that multiply to be 24 that you can make add up to be negative 2? Well, hopefully you're thinking 4 and negative 6. So this will factor into x plus 4 and x minus 6 equals 0. Go get your two answers, negative 4 and 6. So if you recognize the factoring type, that's the fastest. Here's number 9 and 10. I got 4x squared minus 12x. I could use the quadratic formula. If I do, a is 4, b is negative 12, c is 0. But that's not the best way. If you look on your factoring flowchart to the far left, this is one of those they have something in common. If you recognize it, watch how easy this is. I'm going to factor out a 4x, which leaves an x minus 3. Set that piece equal to 0 and get 0. Set that piece equal to 0 and get 3. And then you got it. What you want to be able to do is get these answers and make sure they're correct, but get them as fast as you can. On number 10, peek at that one for just a second and see what you think. As soon as I see a number right there, I don't want to try to factor it. I'm definitely not going to do completing the square. It's not a perfect trinomial, so I'm going to use the quadratic formula again. So if I do that, I got the opposite of b, so negative 4 plus or minus the square root of 4 squared minus 4 times 5 times 2 all over 10. This becomes negative 4 plus or minus. If you run that through, you get the square root of negative 24 all over 10. Now we got to break down the square root of negative 24. I know there's going to be an I in my answer, so I'm going to break this down into the square root of negative 1, the square root of 4, the square root of 6. So I'm going to have negative 4 plus or minus. The square root of 4 is 2. Square root of negative 1 is I. Radical 6 all over 10. And then we're almost done. Do you see a number that will go into 4, 2, and 10? A 2 does. So negative 4 divided by 2 is negative 2 plus or minus. 2 divided by 2 is 1, so I have an I radical 6 all over 10 divided by 2 is 5. And then we got it. Hang with me on the last two, and then we got our whip. Here's my number 11 and 12. You might think about which method is going to be best to use. But as soon as I see a number in front of that x squared that I do not know the square root of, I'm going to go grab the quadratic formula. In this case, a is 6, b is negative 1, c is negative 15. So I'm going to have 1 plus or minus the square root of negative 1 in parentheses squared minus 4 times 6 times negative 15 all over 12. Now I'm going to have 1 plus or minus the square root of something over 12. And since it's a video and I don't want it to last forever, I already ran that through and it's 361. Lucky for us, the square root of 361 is 19. Now go get our two answers. 1 plus 19 is 20 divided by 12. A better answer for 20 divided by 12 looks like a 4 goes into both of them. 5/3. And then my other answer, 1 minus 19, negative 18 over 12, negative 3/2. Then I have one more to go over with you. But if you think you're good, you can stop the video and get rolling on your assignment. But that's what the lesson is, guys, picking the best method. Hopefully you've looked at number 12 now. You might think perfect trinomial. That's a good start since we know the square root of 4, but we do not know the square root of 7. So we're stuck with the quadratic formula again. So here goes. The opposite of b is 12 plus or minus the square root of, in parentheses, negative 12 squared, minus 4 times a times c, all over 2 times my a value, which makes it 8. Now I get 12 plus or minus the square root of. If you run the discriminant part through, the b squared minus 4ac, you should get 32 on that one. And hopefully you know the game there. We got to break down the square root of 32. So something I know the square root of might be 16 times 2 over 8. So this becomes 12 plus or minus 4 radical 2 over 8. And then you have to see if you see a number that goes into 12, 4, and 8. And it looks like 4 definitely does. So this becomes 3 plus or minus the square root of 2 all over 2. Boom. And there we got our answers. So guys, here's the lesson for the day. Keep that factoring flowchart in front of you. So first off, see if something will factor. If it won't factor, see if completing the square works. A is 1, B is even. Third option, quadratic formula. There's a fourth option, but the quadratic formula is better than it. So that's the lesson in 22 minutes. Good luck.